for section 10.1, a couple of word problems here at the end. The first one, it's given that f of x equals x plus 4 squared. Find all values such that f of x equals 24, and what are the points on the graph of f? And so what we're going to do first is we're going to do this substitution of 24 in place of the f of x. And then you solve this. This would be a square root. Now 24 is 4 and 6. And then I subtract the 4 over. So we have negative 4 plus or minus 2 square root of 6 is for x. That doesn't simplify any. And so this would be answering this part. It says find all x such that. That would be both of those numbers right there. And then it says what are the points on the graph? So remember, point, it's an ordered pair, and then your x coordinate comes first, and your y coordinate, which in this case is your function value, comes second. So the points on the graph are x coordinate. It's kind of a cumbersome x value, negative 4 plus 2 square root of 6. If you were to actually plot that, you would change it to a decimal to get the approximate location, but we do need exact value here for our answer. The y value is at 24, and then our other point is the one with the minus sign in it. So those would be our points on the graph. In the next example, it says we have a guy wire that is used to support a telephone pole. So we have this telephone pole. That's going to be the ground. This here is our pole. And then we have a wire helping to support that pole. It says that the wire is located 30 feet up the pole and is anchored to the ground 10 feet from the base of the pole. How long is the wire? So we'll assume this is a right triangle. Using the Pythagorean theorem, the wire length is the hypotenuse, and then the pole and the distance on the ground are the A and the B. And then we get 1,000, and you square root and use only the positive because it's the length of a wire. The square root of 1,000, you would use a calculator because in real life I can't cut my wire to the length of a square root of 1,000, but I can cut my wire to be about 31.62 feet. So those are a couple of word problems with solving these square roots.